Hello students, this is Mr. Anderson coming to you with a lesson on graphing linear functions. This year when we look at functions, we're going to look at it from what we call the GNA approach. GNA stands for the Graphing, Numeric, Analytic, and Writing approach. GNA. What that means is each function can be represented, and we're going to learn how to represent it using a graph, numerically with a table, analytically, that is, with an equation, and then we'll have to describe the function that we're dealing with. Today we're going to look at the linear function. So let's look at an example here. Let's say I give you the equation y equals x. This is what we call the parent function for linear equations, okay? And we're going to graph this using an input-output chart, or you guys probably know it better as a table of values. And so what we're going to look at the numbers, the integers between -2, and 3. And what we're going to do is we're going to just take our input, or x values, and put them into our equation y equals x. And so when we put our input in x equals -2, when x is -2, what's our y value? It's also -2. When our input is -1, our y value is -1. And with this equation, y equals x, it's pretty straightforward. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. And same thing with 3. And so now what you have created is you've created ordered pairs, -2, -2, that we can use those ordered pairs now to graph the function. And so our first ordered pair is -2, -2, so we're just going to go left 2 and down 2 and plot that point. Next ordered pair is -1, -1, so we're going to go left 1 and down 1, plot that point. 0, 0, which is right on the origin. 1, 1. 2, 2, and 3, 3. And what we're going to do is we're just going to connect all of our points. The arrows on the end. We put the arrows on the end because these, in fact, do go on forever. This is just a sample of different values here on the table. Okay. Now, we need to be able to describe this function. This function forms a line, so this is what we call a linear function. All right. Let's look at a more involved example here. This is the equation y equals 3x minus 1. They give us the input values. All we have to do is find the output values. So let's put that in our chart here. We have 3 times our x value is -2 minus 1. Make sure you use correct order of operations. 3 times -2 is -6. -6 minus 1, -7. Our next input value is -1. So we have 3 times -1 minus 1, which is going to be -4. Our next input value is 0. 3 times 0 minus 1 gives us an output of -1. When we input 1 into our equation, we get an output value of 2. when we put in 2 for x, 3 times 2 is 6, 6 minus 1, 5. And y equals 3 times 3, which is 9, minus 1 is 8. Again, you have a set of ordered pairs now, -2, 7. So we're going to go left 2 units, down 7. Left 1 unit, down 4. Next ordered pair is 0, -1. 1, 2. 2, 5. And 3, 8. And now we can connect our points. We have a nice linear function. Couple things I could ask you about this. First off, I could ask you to describe the function. You'd have to tell me that it is linear. Next thing I could ask you is, what is the y-intercept? And the y-intercept is just where it crosses the y-axis. It's right there. So what is that ordered pair? It's 0, -1. Do this last one on your own, try it by yourself, and then come back and check it. You'll have to pause the video. Here, y equals 1/2 x minus 7. So we're going to input your x values in. Half of -4 is -2. -2 minus 7, -9. Half of -2, -1. -1 minus 7, -8. Half of 0 is 0 minus 7, -7. Y equals 1/2 of 2 minus 7. That's going to be -6. Y equals 1/2 of 4. Half of 4 is 2. 2 minus 7, -5. And then half of 6 is 3. 3 minus 7 is -4. We're going to go ahead and plot these ordered pairs, -4, -9. -2, -8. Zero, -7. 2, -6. 4, -5. And 6, -4. Go ahead and connect your points. And there it is. Question for you is describe the function. It is obviously linear. What is the y-intercept? It's that point right here. It's going to be 0, -7.